The inverse transform of that is at time t, right? It's t e to the minus 2t. Now I got to go back to last time we learned this theorem for taking inverse transforms when there's exponentials floating about in the S domain. They create unit step functions and we go back to the t domain. And so thus y, which is, by the way, the inverse Laplace transform of big Y, so that tells me y of t is equal to, okay, so we get 1/4 minus 1/4 e to the minus 2 parentheses. So I have to replace t with t minus pi here, right? Minus 1/2 t minus pi e to the minus 2 parentheses t minus pi. Every place there was a t, I have to replace it with t minus pi. All gets multiplied by u of t minus pi. All right, what I wrote in blue and what I just wrote in black in the answer, this is all due to the unit step function's influence on the system, right? And then the other piece, which is red, we get plus t minus 2 pi e to the minus 2 parentheses t minus 2 pi. And then unit step function of t minus 2 pi. And I suppose you could try to simplify that or something, but I think that's a perfectly good answer right there. I actually prefer to leave it in terms of unit step function as opposed to a case-wise defined function over here. This is case-wise defined, right? That's in terms of unit step functions. For unit step functions, to me, the advantage is you can just kind of look at it and see what's going on in terms of this discontinuity in the forcing function and how the system responds to those discontinuous forces. Any questions? So is the method clear? I mean, we take the Laplace transform of the given differential equation, we solve for big Y, and then we use the technology that we've developed to take the inverse transform to get back to little y. That's it. So there's one other tool I have to teach you after the break, which is called convolution. I'll do that. It should take us about 15 minutes. I'll probably spend about another 10 minutes talking about something called the transfer function and maybe a little bit about Green's function, which is really, I think, interesting, important, but a little beyond this course. And then we'll turn the page and we'll start power series methods. So thanks, guys. You can hit it.